Good afternoon, friends. Welcome to the lecture of real analysis. Okay, this is the third lecture we are conducting today on basic notions of real analysis. In the last lecture, we have seen the definitions regarding limit point, adherent point, open set, closed set, what is the derived set, what are the bounds of the given set. Okay, also we have seen why there is a need to define upper bound, least upper bound, uh, greatest lower bound, etc. Okay, this is what a basic we have taken yesterday. Now in today's lecture we will try to understand the some basic notions regarding sequences. Okay, sequences, rather real sequences I will call. We will deal with real sequences. Okay, can anyone tell me a definition of a sequence? What is a sequence? We will try to understand. Then we will go for knowing what is the limit point of a sequence, what is the convergence of sequence, etc. Correct? Anyone from students, whether they were knowing what is the definition of a sequence? What is sequence? Have you studied sequences previously in your graduation? Yes, students. Am I audible clearly?
Yes, madam.
Okay, good. What is sequence then? Hmm? Yes. What is the sequence? Okay. I think you are knowing the symbol representing the sequence. So the symbol we are using now, SM. And how the terms of the sequence we are writing as S1, S2, S3 and so on. Okay. But what is basically sequence? Basically, sequence is a function. Sequence is a function whose domain is set of natural numbers and codomain is set of real numbers. Why I am considering set of real numbers? Because here we are considering a real sequence. If you are considering a complex sequence, your domain may change correspondingly to the field of complex number. Okay. Therefore, this f is a function from natural numbers to set of real numbers. Okay, and the symbol we are using for the sequence is like this, where S1 represents the first term. Because what are the elements in the natural number? Natural number starts with 1, 2, 3 and so on. Therefore, if I will find f image of 1, f image of the first element 1, f of 1, we will denote it by S1. F image of 2, we will denote it by S2 and so on. That's why the domain should be a natural number so that we can give the numbering to the elements of the sequence as 1, 2, 3 or first element of the sequence, second element of the sequence, third element of the sequence and so on. Okay, therefore this is just a function. Before this also one can have a question. What is function? Can anyone answer what is function? It's a very basic aspect, no, actually. What is function? Yes? What is function? No one is knowing what is function? Or you have decided today not to speak? Huh? If you are doing...
Binary relation between two sets.
Yes, relation.
If any two sets like A and B, then every element in A has a unique images in B. Then we say
Good.
that the function.
Yes, every element, suppose it is a relation I am going to define from A to B. Then every element in A should have a unique image in B. Correct? Then there are some properties of the functions. What are the properties of the function? 1, 1, 1, 2, into. Correct, na?
Yes, ma'am.
Correct, na? Now, I don't want to go to this part actually, but you should know what is 1, 1, what is onto, what is well-defined function. Okay, and while proving, you may take this as a homework and you can recall me tomorrow so that we will go for. In 1, 1, what we are proving actually?
If the images are equal, then these two elements are also equal.
f of a is equal to f of b will
Then A is
imply
equal to B.
a is equal to b. But from this, how can you say that the function is 1, 1? How can you understand this fact? How can you understand from this statement f is equal to fb implies a is equals to b? How can you come to know that this is a 1, 1 function? Okay, function and its properties, if the time permits, we will take in today's lecture, or we will take this in the next lecture. Come to the sequences. This is a today's homework you can consider. Okay, 1, 1. For onto what you are defining, what is well defined? Many questions are there. Okay, coming back to sequences first. We will complete the sequence part. Okay, therefore function is a relation where every element in the domain is having unique element in the codomain. And why the domain is natural number always? Just to number the elements of that function. First element, second element, third element, and so on. It has to be the natural number. This is a sequence. This is a sequence. Can anyone tell me an example of a sequence? A best example, a simple example I can define is 1 by n for n in n. Correct now? Sn is 1 by n for n is in n. Then what will be the nature of element in the sequence? First element is 1. Correct now? What is second element? 1 by 2.
1 by 2.
Third element? 1 by 3. 1 by 4. And so on. This is the sequence. All elements are distinct. Correct now? Many examples you have studied already. Sn 1 plus minus 1 raised to n for n in n. Correct now? This is also a sequence. Sn is equal to 2n plus 1, sequence of odd numbers. This is also a sequence. Many types of sequences we have defined. Okay, let me try to define bounds of the sequence. What is bounds of the sequence? And the sequence is said to be bounded above, bounded below. Bounded above. Can anyone define? When we say that the sequence is bounded above.
When lower limit exists.
Bounded above, I am saying.
Or upper limit when exists.
There exists a real number capital K such that Sn is less than or equals to K for all n in n. Correct? That is, for all the elements of the sequence, this K will be working as an upper bound and the sequence is said to be bounded above. Similarly, one can write bounded below. There exists a real number, say small k. Small k I am writing such that small k is less than or equal to Sn for all n in n. And whenever both the bounds exist, whenever both the bounds, below, lower bound and upper bound exist, the sequence is said to be a bounded sequence. Good, it is a bounded sequence. What is convergence of a sequence or limit of a sequence? Definition, convergence of a sequence. I'll write the definition first. A sequence Sn is said to converge to a real number, say small l, converge to a real number small l if for each epsilon greater than 0 there exists a positive integer m or capital N I will write, a positive integer n such that, what such that? Mod of Sn minus L less than epsilon for n greater than or equals to capital N. This is a textbook definition, you know, about the convergence of a sequence. Now you have to tell me the meaning. What you have understood with this? How this for every epsilon there exists a positive integer. What is epsilon? Epsilon is a positive number. For every positive epsilon, you should have one integer. Okay, in other words, this integer is called as a stage, after which all the sequence elements are going to or this inequality is going to hold. Okay, actually what is the meaning of this statement? See, whenever I'm writing mod x is less than L, what does it mean? Minus L less than x less than plus L. Correct now? Similarly, if I write here, this is minus epsilon less than minus Sn plus 1 less than plus epsilon. No doubt for all n greater than or equal to. Let me add L throughout. Therefore, it gives us L minus epsilon Sn less than L plus epsilon. Means all the sequence points should lie in the interval, in the rather the open interval. In which open interval it is going to lie? L minus epsilon to L plus epsilon. And from where? From n greater equal by capital N. Correct now? I'll just try to illustrate this. Okay. Suppose this is the real line. Okay. And if I'm going to plot the elements, say this is my first element S1. Okay. Say this is my second element S2. Say this is third element S3 and some. And we are going to continue. And there exists a positive integer capital N. Okay, say somewhere here this capital N exists. Here it is 1, 2, 3. Somewhere here it is capital N. What is the corresponding element of the sequence here? This is Sn. And what the statement says? All the sequence points from capital N and onwards. Right? Therefore, what are the sequence points? Actually, these are n, n plus 1, n plus 2 and so on. All these sequence points should lie in this open interval, L minus epsilon to L plus epsilon. Let me mark my L somewhere here. Let me mark my point somewhere here, or let me come somewhat closer. Okay. Okay, then we have to find out the open interval around L with the distance epsilon on the left, with the distance epsilon on the right also. Correct. Therefore, let me make the positions. Let me mark the positions somewhere here. This is L plus epsilon and this is say L minus epsilon. And all the sequence points Sn, Sn plus 1, Sn plus 2 are going to fall in this open interval, and whenever such a L exists, whenever such a N exists, then we are going to say that the sequence is going to converge to a limit L. Sequence is going to converge to a limit L. Is this fact clear to everyone? With this geometrical sketch, is the sequence convergence clear? If you have a doubt, you can ask me at any stage. Is this point clear to everyone? Correct. लक्षात येते का? समजलं का हे एक्झाम्पल?
Yes, ma'am.
ओके, गुड. आणखीन सोप्या भाषेत जर सांगायचं असेल सिक्वेन्स कन्व्हर्जन्स, तर मी नेहमी क्लासमध्ये एक छोटंसं एक्झाम्पल सांगते विद्यार्थ्यांना. काय एक्झाम्पल सांगते माहिती? समजा एक शाळा आहे आणि त्या शाळेमध्ये आपण प्रार्थनेची वेळ असते आणि प्रार्थनेनंतर आपण वर्गात विद्यार्थी कसे जातात माहिती ना सगळ्यांना? पहिली ओळ जाते, त्याच्या मागे दुसरी ओळ जाते, बरोबर ना? शिस्त असते ना शाळेमध्ये, बरोबर की नाही? आहेत ना स्टुडंट्स मजा?
हो आहे.
हो मॅडम.
तर काय होतं मग अशा वेळेस? काय होतं, एक पहिली ओळ गेली की त्याच्या मागे दुसरी ओळ जाते, मग तिसरी ओळ, अशा जातात ना वर्गामध्ये विद्यार्थी, बरोबर? तसंच आता चाललेत समजा विद्यार्थी आणि त्या शाळेच्या ग्राउंड मध्ये एक कोणीतरी फेमस स्टार, सुपरस्टार आले. तुम्हाला कुठला हिरो किंवा हिरोईन आवडते मला सांगा बरं, कोणी सांगा. कोण आवडतं? कोण आहे तुमचा आवडता हिरो, आवडती हिरोईन? सांगाल कोणी? का माझ्या आवडीचा घेऊ? कोणता हिरो आवडतो, कोणती हिरोईन आवडते, कुठल्याही एका विद्यार्थ्यांनी सांगायचं. नाही आवडत कुणाला, कोण मूवी बघत नाही वाटतं कोणी. नाही बघत मूवीज कोण? हॅलो, चला माझं
ऐश्वर्या
चालू. कोण?
ऐश्वर्या रॉय.
ऐश्वर्या राय. आता समजा तुमच्या त्या पटांगणातून सगळे विद्यार्थी वर्गात चाललेत आणि तिथे ऐश्वर्या राय येऊन थांबली तर काय इफेक्ट होईल त्या लाईनवर, एवढं फक्त इमॅजिन करायचं आपल्याला. काय होईल समजा सुरुवातीची एक पहिली ओळ चालली समजा आणि ते विद्यार्थी जे आहेत ना अतिशय सिन्सिअर आहेत आणि ते काय करणार आहेत, मग ऐश्वर्या राय जरी उभारली असेल तरी ते काय करणार आहेत, गपचूप वर्गात जाणार आहेत, सरळ 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 वर्गात. ओके. आणि मग काय होईल समजा एक 10-15 विद्यार्थी गेले, असे सिन्सिअर विद्यार्थी संपले, पुढे गेले. आणि काय होईल समजा 15 विद्यार्थी गेलेत आणि 16व्या विद्यार्थ्यापासून बाकीचे सगळे काय करणार आहेत, तुला पण त्या 16व्या विद्यार्थ्याला ती ऐश्वर्या राय हिरोईन जी आहे ना ती खूप आवडते, मग ते काय करणार, लाईन सोडेल ना तो किंवा ती आणि कुठे जाणार आहे, ऐश्वर्या राय पाशी जाऊन थांबेल ना ऑटोग्राफसाठी. ऑटोग्राफचा जमाना गेला म्हणा आता, काय सेल्फीचा जमाना आहे, सेल्फीचा जमाना आहे. तसं सेल्फीसाठी तो काय, ती विद्यार्थिनी काय करेल, ऐश्वर्या रायच्या जवळ जाऊन उभारेल. आता एक जण जाऊन उभारला म्हणल्यानंतर पुढच्याला काही प्रॉब्लेम आहे का, तो पण जाऊन उभारेल ना. हळूहळू काय होईल म्हणजे बघा, अशा आपले विद्यार्थी चालले, ही आपली शाळा आहे आणि इथे ऐश्वर्या राय उभारलेली आहे. तर हे असे एक सुरुवातीचे 15 विद्यार्थी गेले सरळ वर्गात आणि हा जो 15 गेले आतमध्ये, हा 16वा काय करेल, असा इथे येईल आणि ही ऐश्वर्या राय आहे आपली, तो इथे येऊन उभारेल. मग पुढचा पण काय करेल, इथे येऊन उभारेल. असं सगळे काय करतील, इथे गोळा होतील की नाही, गोळा होतील ना. कोणाच्या शेजारी गोळा होणार आहेत सगळे विद्यार्थी, ऐश्वर्या रायच्या शेजारी. म्हणजे असं म्हणेन का मी ऐश्वर्या रायच्या नेबरहुड मध्ये सगळे आले विद्यार्थी, बरोबर. हे सगळे ऐश्वर्या रायच्या नेबरहुड मध्ये आले म्हणजे ही सिच्युएशन झाली की नाही. म्हणजे इथे एल कोण आहे, लिमिट ऐश्वर्या राय आहे आणि एसएन पर्यंत, म्हणजे एसएनच्या मागचा सिक्वेन्स एलिमेंट कोण आहे, n-1 आहे की नाही. म्हणजे कुठला एलिमेंट, SN-1, म्हणजे S1 to SN-1 पर्यंतचे विद्यार्थी जे पॉइंट्स आहेत ते शहाणे, ते सरळ गेले वर्गात आणि SN पासून सगळे कुठे आले, याच्या नेबरहुड मध्ये, म्हणजे या ऐश्वर्या रायच्या नेबरहुड मध्ये आले. तसंच हे एलच्या नेबरहुड मध्ये आले ना, बरोबर. तर याला स्टेज कुठली म्हणणार आपण, कॅपिटल एनच्या नंतरचे सगळे त्या एलच्या नेबरहुड मध्ये आले. म्हणून इथे एल ला काय म्हणणार आहोत आपण, एल इज कॉल्ड एज द लिमिट point of sequence. That is, a very situation was very simple, that if after n and onwards all the sequence points are going to fall under the neighborhood of some element. Okay, this is the neighborhood of L, na? L minus epsilon to L plus epsilon, correct. Then all the elements are going to fall under the neighborhood of this L. Therefore this sequence is said to converge to L. मग तुमच्या ह्या एक्झाम्पलचा लिमिट पॉइंट कोण आहे सांगू शकाल का, म्हणजे एक्झाम्पल मी सांगितलं ना शाळेचं विद्यार्थ्यांचं, याचा लिमिट पॉइंट कोण झाला त्या सिक्वेन्सचा,
ऐश्वर्या रॉय.
ऐश्वर्या राय, करेक्ट ना. आणि आपल्या या सिक्वेन्सचा लिमिट पॉइंट कोण झाला, एल, करेक्ट ना. For a very simple definition, it tells us that whenever after some stage and onwards, after n and onwards, if all the sequence points are going to fall under the neighborhood of a point L, correct, then L is said to be a limit point. And this is very similar to the limit point definition we have seen in the last lecture. If I collect all the points S1 to Sn and so on, then this is as per our definition, correct now. L is a limit point if every neighborhood contains infinite elements of the given set. Whether this neighborhood contains infinite element of the given set or not. Yes, it contains infinite
Yes, ma'am.
elements. Therefore, as per that definition, this is the limit point of the set, range set of Sn. That is the sequence. Correct now? Okay. Now this is clear. Mod of Sn minus L less than epsilon greater than or equals to N. But here this point is not clear yet. Correct now? For every epsilon, there exists a positive integer. Right now, if I'm going to change epsilon, there should be a change on the interval. There should be a change on the stage. Suppose I change the value of epsilon here. If I make the value of epsilon somewhat smaller than the previous one, what is going to happen? S1, S2, S3 and so on. Okay, and here it is L we have marked. Now let me make epsilon smaller so that that neighborhood is going to become smaller. Therefore, this is L minus epsilon to L plus epsilon. Therefore, this is my stage L. Now check whether Sn and onwards elements are going to fall in this neighborhood. No. What we have to go? These elements are going to remain outside the interval. And suppose somewhere Sm exists. Sm exists from which all the elements are going to fall in this interval. Means this stage m changes, na? Here the stage is n because after n onwards, all the elements are going to fall under the neighborhood of n. But here m onwards, the elements are going to fall under the neighborhood of n. Therefore, whenever we change epsilon, this positive integer n m is going to change. Therefore, the definition says that for each epsilon greater than 0, there exists a positive integer. That is your this stage, this positive integer depends on the value of epsilon chosen. Depends on the value of epsilon chosen. Is everyone getting me?
Yes, ma'am.
Okay. Let us take this by example of Sn. Sn is equal to 1 by n for n is in n. What is the limit point we know?
0.
Is the limit point. Right now. Now we'll try to find out for every epsilon how that n is going to change. Okay. Yesterday we have marked it already. What is the first point of the sequence? 1. Second point? 1 by 2, 1 by 3, 1 by 4 and so on. Let us mark the positions of the sequence points. This is 1. Therefore, this is my first element S1. Correct? What is the second element? S2 is somewhere here. Half. Correct now?
Yes, ma'am.
Yes, ma'am.
S3 is somewhere here.
1 by
0.33.
3.
S4
1,
1 by 4,
4.
0.25. Means we are going nearer and nearer to 0. Nearer and nearer to 0. Okay. Now suppose I have given you the value of epsilon to be 0.3. Okay. Now you have to tell me a stage n after which all the sequence points fall in this neighborhood of 0. Neighborhood of 0 with epsilon is equal to 0.3. Therefore 0.3 on the right, 0.3 on the left. No? Correct?
Yes, ma'am.
On the right, 0.3 on the left. Okay, okay, here it is not 0.3. I'll just undo this. This is 0.25 we are marking, na? 1 by 4 means. Therefore, somewhere here is 0.3, na? Correct? To the left also. Correct? Therefore, if I select the value of epsilon as 0.3, what is the neighborhood of epsilon we will have? To the right, it is 0.3. To the left,
Minus 0.3.
minus 0.3. Good. Therefore, this is the selected neighborhood with epsilon value is equal to 0.3. Now, you have to tell me the value of n after which all the sequence points fail under this neighborhood 0. Minus 0.3 to plus 0.3. Can anyone tell me n stage सांगाल का कुठला n इथे येईल? Whether n equal to 1 is there? N equal to 1 is here. Whether this 1 fall under this neighborhood? No. If I take n is equal to 2, here is the location. Correct, na? For n equal to 1, here is the location. It is not in this neighborhood. For n equal to 2, here is the location. Again, this is not in this neighborhood. For n equals to 3, here is the point, 1 by 3. Still, we are not in this neighborhood. But what for n equal to 4? For n equals to 4, the value is 0.25. Correct, na? Whether 0.25 fails in this interval?
Yes, ma'am.
Yes, it is. Therefore, may I say for n equal to 4 and onwards, May I say all the remaining points are also there in the same interval?
Yes, ma'am.
Therefore, may I say the value of n is 4 here?
Yes.
Good. The value of n is 4. Therefore, what is the first value we have found out? For epsilon is equal to 0.3, the value of n is 4. That is after n equal to 4, that is n equal to 4 and onwards, all the values of the sequence points fall under this neighborhood for L is equal to 0. Let me change this. Let me change the value of epsilon now. Let me make it as 0.1. Okay, then what is the neighborhood? 0.1 on the right of 0, 0.1 on the left of 0.
0.1 to point
Minus 0.1 to plus 0.1 will be the interval. Now, here will be somewhere the location is. I'll change the pen again. Here is somewhere is the location, na? Correct? Now you have to tell me the value of n after which or from onwards all the values of the sequence points fall under this neighborhood of 0 with epsilon value 0.1. Is Samta?
11.
Yes, 11. Because if I take n equal to 10, the value is exactly 0.1, but 0.1 is not going to belong to this interval, na? Because we are taking this as an open interval. Therefore, exactly correct answer, the value is 11. Correct? Therefore, for epsilon is equal to 0.1, what is the stage we have obtained? 11. Correct? Let me change again. Epsilon is equal to 0.01. Still smaller. Answer.
101.
Yes, it is 101. Okay. Now you can check for taking different values of epsilon. Do you understand this relation now? For every epsilon, there exists n. I want to just make this statement clear to you all. For every epsilon, there exists a positive integer such that this statement holds. What is the meaning of this statement? The sequence points from n and onwards are going to fall under epsilon neighborhood of the point n. Under epsilon neighborhood of the point n. And if it happens, the sequence is said to be convergent. If it do not happen, it will not be a convergent sequence. Correct? I hope I'm very clear to all. Right? So if I take another example, say 1 plus minus 1 raised to n. 1 plus minus 1 raised to n. What are the sequence points? What is the first point for n equal to 1? If I take n equal to 1, what is the value? Here it is minus 1. 1 minus 1, 0. For n equal to 2,
2.
2. Again for n equal to 3,
0.
0. Means it's an oscillating sequence. Correct?
Yes,
Na?
0 to 0.
Yes, ma'am.
This is an oscillating sequence. Okay. Now how many points we have in the range set? Only 2 points. 0,
2 points.
2. Correct now? Only 2 points we have. Therefore, if any point has to be a limit point of this, what the condition says that after n and onwards, all the sequence points should fall under this neighborhood. That is, this neighborhood should contain infinitely many points of the given sequence. But is it true in this case? We don't have infinitely many points. Therefore, there is no question to have a limit point. Or, according to the second definition of a limit point, okay. Therefore, this sequence, may I say it is not convergent? 0 to oscillating sequence, no? 0 to is a oscillating sequence. Okay. Now I don't want to go for much of the examples. Okay. What I will go for properties. Any doubt about this? This sequence 0 to.
No, ma'am.
0 to 0 to you will get. Correct. Now we have studied one theorem that every convergent is bounded. Correct, na?
Yes, ma'am.
Sequence is bounded. Can anyone answer me why every convergent is bounded?
Ma'am, because in the convergent sequence definition itself, it has
Mhm.
interval L minus epsilon and L plus epsilon, in between which sequence is bounded.
Very good, very good. In the definition itself, it was said that Sn belongs to L minus epsilon to L plus epsilon. But this is the case for capital N and onwards, no? What for the previous one? Whether those are also bounded? Yes, you are correct. The answer you have given is very correct. S1, S2, for Sn and onwards, all are in this interval. Correct now? Therefore, if I am saying it is in the interval, it is bounded. What? How many elements are there outside the interval?
Finite.
Yes, it is finite. S1 to Sn minus 1. And what is the fact? We know. Finite set is always bounded.
Bounded.
Therefore, here S1 to Sn minus 1, this is bounded. For the remaining, it is also bounded. Therefore, combinedly, we can say that the convergent sequence is always bounded. Correct now?
Yes, ma'am.
Now, by using that limit point of a sequence, one can limit point of the set, one can define the limit point of a sequence. What is the definition of limit point of a set we have seen in the last lecture? Every neighborhood of zeta contains infinite members of the given sequence, and that's why this L is called as limit point of the given sequence. This is called as limit point of the given sequence. Can anyone tell me the criteria regarding the limit point, whether the limit point of the given sequence is unique, not unique, etc.?
It is unique, ma'am.
Always it is unique.
Convergent sequence has a unique limit point.
Convergent sequence has unique limit point. That is correct. But for every sequence, you cannot say
Unique
correct,
limit
na?
point.
For every
Yes,
sequence, you
ma'am.
cannot say. That is what I have skipped this example actually. Because if I want to check whether 0 and 2 are the limit points of the sequence or not. May I say 0 and 2 are the limit points? Are the limit points I'm saying. Why? Because there are infinite zeros in the sequence. 0, 2, 0, 2. Okay. Therefore, in the neighborhood of 0, these many infinite points comes na, of the given sequence.
Yes, ma'am.
Yes.
Therefore, this neighborhood of 0 contains infinite points of this sequence. Therefore, 0 is a limit point. Correct. Similarly, what about 2? In the neighborhood of 2, again there are infinite points of the given sequence. Therefore, this is also a limit point of the sequence according to the definition. Right now?
Yes, ma'am.
Yes.
Therefore, the sequence may have many or may not, the limit point may not be unique. Okay. One example also there, na? Which example? Suppose I'll write minus 1 raised to n for n equal to for any n. What are the limit point? What are the sequence points?
1
1,
minus
1
1.
minus
minus
1.
1, 1, minus 1, 1. Correct, na? Again, with a similar situation, may I say minus 1 and 1 are the limit points? Because in the neighborhood of this minus 1, how many points of the sequence come? Infinite.
Infinite.
Again, in the neighborhood of this plus 1, infinite points come. Therefore, these two sequences are the good examples of the sequences having two limit points. Having two limit points. Therefore, the sequence are not convergent sequences. A sequence is said to converge if it has unique limit
Only one limit one.
only one limit point. Is this point clear to everyone? Every convergence is bounded. It may have many limit points. Correct now?
Yes, ma'am.
Okay. What about a Cauchy sequence? Do you know Cauchy sequence? Sanga. Cauchy sequence. The sequence Sn is said to be Cauchy if
It is convergent
There
sequence.
exists an nm greater than n, that is mod of Sn minus Sm is greater than or equal to epsilon.
greater than or less than
Less than.
Less than,
Sorry.
strictly less, na?
Strictly less than.
For all n m
N m greater than
greater than equals to
belongs
n.
correct.
capital N.
Correct na? Again, same statement na. Sn is a sequence for every positive epsilon, that is for every epsilon greater than 0, there exists n m. Okay, there exists a stage n where for n m greater than or equals to n, these statement holds. Correct na? Sn minus Sm less than epsilon. Therefore, again, what the situation says? Distance between the 2 points. Correct na? Again, this I'll mark the sequence points as done previously. Suppose here is somewhere n. Therefore, what is the corresponding sequence point? Sn. Right now, n is the stage again. After this stage, or the difference between the two sequence points should less than epsilon. Therefore, one can say that again minus epsilon less than Sn minus Sm less than plus epsilon. Therefore, this is going to, the difference between the 2 points is going to be less than epsilon. Correct na? Okay. Therefore, what is the statement is saying? If suppose this is Sn and this is Sm, what should be a distance between the two?
Less than epsilon.
Epsilon. Correct na? Means distance is less than epsilon means what? As you reduce your value of epsilon, as you make epsilon smaller and smaller, these points are coming closer and closer. Right or no? These sequence points after n onwards, all the sequence points, or rather every pair of sequence points coming closer and closer. This is what our meaning is. And if they are coming closer and closer, one can mark one neighborhood so that all the points will fall under this neighborhood. All the points will fall under the neighborhood. Therefore, we know a statement, every convergent is Cauchy. Correct, na? Every convergent sequence is Cauchy. Why every convergent is Cauchy? Because here we have stated the reason, na? This stage you can consider. If this is a convergent sequence, all the sequence points are going to lie under this neighborhood of L minus epsilon to L plus epsilon. Therefore, if I take any 2 points in between the two, in between this neighborhood, Sn and Sm, what is going to be a distance? The distance is going to be less than epsilon. We are going to take all the points closer to one another. Therefore, every convergent sequence, as this all sequence points are going to fall under this neighborhood, or I can adjust the neighborhood here. Epsilon by 2 is going to be less than epsilon by 2. Epsilon by 2, epsilon by 2. Na? If I take any 2 points between this interval, between this neighborhood, this Sn minus Sm is going to be less than epsilon. Therefore, an obvious statement we are getting, every convergent is Cauchy. Converse need not be true. Converse need not be true. Okay. Yes. Is it clear? Cauchy sequence also?
Yes, ma'am.
Yes, ma'am.
Good. Okay. Now shall we come to that point of function? One bounded. One on two. Because I want you to clear all the points first thing. A function is a relation actually. A function is actually a relation, means it is a set belonging to the Cartesian product, subset of Cartesian product A cross B. Now, first thing we want to discuss is 1 set. Okay, no doubt the definition of this function is relation in which function is a relation in which every element in A has unique element in B. This is the definition of a function. Now we are going to say that the function is 1, 1. Okay, according to Venn diagram, we have studied in 12th standard, A to B. What is 1, 1? Means for every one element in A, there is one element in B. Na?
Yes, ma'am.
What is the another type? Many one. Common many.
Many one.
Many one. One many येत नाही का? This is one. This is many one, na? Third is what is this? Third one?
One many function.
One many. But is it a function first?
No.
Is this a function?
Into
Huh?
into function.
Is it into
No,
function?
ma'am, it is not function.
Yes, it is not function. Because for one element we have two different elements. Therefore, this is not function. Therefore, there are only two types of a function. One and many one. Okay. Now we will find out what is one. One means for every one element in the domain, there is one or unique element in the codomain. But while proving, what you are proving actually, if I want to prove the function is one, you are proving f is equal to fb implies a is equal to b, na?
Yes.
Can anyone answer me by proving this? How can you come to know that this is one? हे असं प्रूव्ह केल्यानंतर तुम्हाला कसं समजतं की हा वन आहे? मला तर नाही समजलं. कोणाला समजलं असेल तर मला प्लीज सांगा कसं कळालं याच्यावरून.
Different elements have different images.
Good. Then this is the definition. Different elements have different
Images.
images. But whether we are proving this statement, different elements have different images means what should I prove actually? A not equals to b implies
F of A is not equal to
Not equal to f of b.
असं प्रूव्ह करायला पाहिजे ना मग. आपण
Yes,
असं
ma'am.
प्रूव्ह करतो. Why we are proving like this?
Negation of negation.
Good. Explain. Correct. You are correct. Contrapositive statement we are using. Different elements have different images. What is the contrapositive statement? P implies Q. What is the contrapositive statement?
Minus Q implies
negation
minus
of Q implies negation Q.
Minus, right? Is it minus?
negation.
Negation.
Of P implies negation.
Now explain how we are proving this one and how we are going to do this. This is a definition and this is what we are proving. Yes, students. Anyone know this? P statement implies Q statement. Contrapositive statement tells that negation Q implies negation P. If I take the statement P as A not equal to B, what should I prove? F of A not equals to F of B. What is the negation of my Q?
F of A equal to F of B.
Then
It implies
what we are going to imply?
A is equal to B.
Correct. Therefore, this is, yes, correct. Therefore, we are, instead of proving this, okay, we are not proving any statement starting with an inequality. We are always proving a statement with equalities. That's why instead of using this part of the proof, we are using a contrapositive statement so that these inequalities get converted to equalities. Okay, and we can prove the function to be one very easily. Okay, next, today's question I am going to give you is regarding well defined. Okay, Today's question is, what is the meaning of function is well defined? Okay. And how we are proving this well definedness? Exactly reverse we are doing, na? A equal to B implies F equal to FB. Now you have to answer me what is well defined and why we are doing this procedure. And with this, how can you come to know that the function is well defined? Okay. We will stop for today. In the next lecture, we will go for understanding what is a continuous function, what is uniform continuous, with the definition and with the geometrical aspect as well. Whether if you have any doubt regarding today's lecture, you can ask me. From student points, if you have any doubt, you can ask me. Today's question you have to keep in mind what is well defined and why we are proving like this and why there is a need to define well definedness. Okay. Thank you for watching the lecture.